Okay, in this assignment, we're going to talk about how to solve one-step equations and two-step equations, and there's going to be some tricky ones along the way. But basically, for any type of equation that you're trying to solve, you're looking to undo whatever operation is happening in the problem. So we're going to do the opposite of what is happening in the problem. So if you see addition, we're going to subtract. If you see subtraction, you're going to add. If you see multiplication, you're going to divide. And if you see division, you're going to multiply. And again, there's going to be some exceptions along the way, but for the rule, whatever operation is happening in the problem, you will do the opposite. And you're going to do that until you can isolate the variable. I know you've heard that term before. You're going to try to get the variable all by itself on one side of the equal sign. It doesn't matter which side, the left or the right. It does not matter. So if I see a problem like number 1, I see my variable here. I'm going to try to get that by itself on this side of the equal sign, which means I have to get rid of this plus 12. The opposite of addition is subtraction. So if I minus 12 from that side, that will leave me with the variable all by itself. However, you have to remember that if you do something to one side of the equal sign, you have to do the exact same thing to the other side of the equal sign. So 10 minus 12 would be negative 2. And now that I have the variable by itself, I have my solution. I can check my solution by plugging negative 2 back into the problem. Negative 2 plus 12 would be 10. So I know that that is correct. So remember, when you're solving equations, remember this is very important. I'll say this over and over again. You can do anything you want to an equation. Anything. As long as you do it to both sides of the equal sign. Okay. So in this problem, it's pretty obvious that I have subtraction going on here with the variable. So undo that subtraction. I'm going to do the opposite. So I'm going to add 9, which will cancel that out because negative 9 and positive 9 equals 0. But if I do it to one side of the equal sign, I have to go across to the other side of the equal sign and do the exact same thing. Negative 2 plus 9 is 7 equals G, and that should be my solution. If I plug this back in to see if this is true, 7 minus 9 is negative 2, so I know that that is correct. Okay. Number 3, I have multiplication going on. If I have multiplication going on, the opposite of multiplication is division. So I'm going to do the opposite of the operation. Okay, so a lot of students want to add 7 here because they see the negative 7, but this is not a subtraction problem. This is a multiplication problem. And the opposite of multiplication is division. So I'm going to divide both sides by whatever number is here. Not the opposite of the number, the opposite of the operation. The opposite of multiplication is division. So I'm going to divide by negative 7. So these will cancel out, and this right here will not divide. Actually, it will divide evenly. Negative 91 divided by 7, I believe, is 13. That's true. If I plug that back in, negative 7 times 13, plugging it back in here for y, equals negative 91. Negative 91 equals negative 91. Okay? Here we have division. We're trying to get the variable by itself. Undo division with multiplication. So I'm going to multiply both sides by 9, and when I do that, these cancel out and leaves me with the variable by itself. Negative 4 times 9 is negative 36. Okay. These next set of problems have fractions in them. They are still considered one-step equations because I can take care of this and get the variable all by itself with one step. If you remember, we learned the inverse property of multiplication that says if you take a fraction and you multiply it by its reciprocal, you end up eventually with the number 1. Well, if I'm trying to get x by itself, remember, a variable without a number in front of it implies that this number is 1. So I need to turn this guy 2/3 into 1, and I can do that by multiplying by the reciprocal. 3/2 times 2/3 is 6 over 6 which is 1, x, or just x. Okay? If I multiply one side, I got to multiply the other side. So a little refresher on multiplying fractions. If one's a fraction and one's not, make them both fractions. Multiply the top times the top and the bottom times the bottom. And 30 divided by 2, always see if that will reduce. It will. That would be 15. Okay? Number 7, multiply by the reciprocal. Negative 5 over 6. Both sides. Here, you're going to end up with 1k, or just k, because remember, when you multiply by the reciprocal, you get 1. Over here, make them both fractions. Top times top, bottom times bottom, and negative 60 over 6 simplifies to negative 10 if you divide those. All right, one-step equations. Moving on, two-step equations. So two-step equations. Here's the rule of thumb. Always undo addition or subtraction first. Which means if there's a number attached to the variable, like this 6, you're going to get rid of that 6 last. I'm going to undo this first. So I'm going to undo that addition with subtraction. So I'm going to minus 8 from this side. I got to go across the equal sign and minus 8 from the other side. So that's gone. I'm going to bring down what I have left over. 6x, and 50 minus 8 is 42. And now I'm left with one more step. This is multiplication. It's not addition. I'm not going to minus 6. It's multiplication. So I'm going to undo multiplication with division. Dividing by 6 gives me x equals 7. Okay? Let's look at number 12. A little bit tougher. Okay? Here's my variable. I got to get rid of all this stuff that's on the same side with the variable. This is attached to the variable, so I'm going to get rid of that last, which means I got to get rid of this first. Now, students will see this subtraction sign, and they're going to want to add 7. But if you add 7 here, 7 and 7 doesn't make 0, it makes 14. Think of it this way. This is a positive 7, so I want to minus 7. That will make it go away. If I minus 7 here, I minus 7 here. That's gone, and what I'm left with here is not 3y, but negative 3y. Remember, if you see a subtraction sign in front of a number, you treat that number as a negative, and it is. It's a negative 3y equals 27. Okay, doing the opposite of the operation. This is multiplication, not subtraction. So I'm going to undo that with division. Undo the multiplication with division, whatever that number is. All right. Okay. Let's look at a couple more problems. 13. Undo the subtraction first by adding 7 to both sides. And you have left over x over 2 equals 16. This is division. How do we undo division? By multiplication. Multiply both sides times 2, and you get the x by itself, and that's 32. All right, so those problems here on the back are all like that problem. Number 17. I'm going to add 10 to make sure that goes away. And I'm left with 7/4 p equals negative 28. Now I'm going to multiply by the reciprocal again, and that will turn into just 1p. Multiply times the reciprocal, make them both fractions. And you're going to get negative 112 over 7. Multiplying the top times the top and the bottom times the bottom. And when you divide these, you get negative 16. All right, a couple last problems here. Number 19, if you notice, this side of the equal sign is all one big fraction. So I need to get rid of the fraction first. This is an exception to the rule where we're not going to undo this addition first, because this guy is part of the fraction. So I have to get rid of the fraction first. And the way that you get rid of a fraction is multiplying by the denominator. Okay, it's called clearing the fraction. Multiply by the denominator, and these 8's cancel, and you're left with whatever was left on top, which in this case is x plus 11 equals, and then when you multiply over here, you get negative 24. Now I undo the addition by subtracting 11. So this is an exception to the rule. You'll find out that in algebra, there's almost always exceptions to the rule. All right, last one, 21. Clear this fraction. This is all one big fraction here. I'm going to clear it by multiplying times negative 6. Now you notice in these problems up here, I didn't clear the fraction first. I would minus 22 first here because this 22 is not part of the fraction. But in this problem, this is part of the fraction, so I need to multiply by negative 6. So I end up with negative 6 over here, negative 6 times 1. These cancel, and I'm left with whatever was on top. Now I have one step left. And that leaves me with 7 equals A. Okay, good luck.